Alright guys, today we're going to be talking about 3-6, which is solving compound inequalities. Some of you may have seen compound inequalities before, and some of you may not have. So this might be new. Just work hard on the notes and we will practice it tomorrow in class together. So copy down your target for today. I can solve compound inequalities in one variable and graph their solution sets. Taking a look at this warm-up, you only have to choose one. So I want you to choose one to solve. Pause the video. This is kind of like what we went over the last two lessons, where you have variables on both sides of the inequality, and it's multi-step. So choose one of these to solve, pause the video, and then you can play it. I'm not going to work them both out, but I'll give you the solutions so you can see if you're correct. Okay, your answers for the first warm-up would be W is greater than or equal to -1 6/7. You could write that as W is greater than or equal to -13/7. I would take both of those. And the second one, X is less than -3. So hopefully you got one of those right. If you didn't, these are very challenging. I just wanted to give you a challenge to start off with from all the practice that we've done with the inequalities. You should be ready for one of them. If you have a question, make sure you ask me tomorrow in class. So you need to be familiar with the vocabulary here. Compound inequality is when two simple inequalities are combined with either the word and or the word or. Okay? So we're going to just classify them as and or, but you can call them either an intersection or a union. An intersection is the overlapping region that shows the solutions of both inequalities. So I might say X has to be less than 5 and X has to be greater than 0. I would only want to graph where they overlap. So even though X is less than 5 may go all the way into the negatives, X is greater than 0 goes all the way to the positives, we only want where they overlap. So here X is less than 5. I'm going to kind of draw just a quick sketch. For that one I would have an open circle and I'd be shading this way. But for X is greater than 0, I would have an open circle at 0 and shading to the right. So if you were graphing just the intersection, those two are kind of like your skeleton for this. Your final graph would be an open circle on 0 and an open circle on 5 and only shading between them. You would not draw the green lines, only the blue here. Okay? So the intersection is only where they overlap. If this number -1 is a solution to one of the inequalities, it's still not a solution to the intersection because it doesn't satisfy X is greater than 0. The other case then is the union. The union is the combined regions that show the solutions of either one of the inequalities. So here I might say X is going to be greater than 5 or X is going to be less than 2. And if it's an answer to either one, then it's a solution to the union. So if I graph this, and graph this one with me please. X is greater than 5. Would have an open circle here and shading to the right. X is less than 2 would have an open circle here and shading to the left. There's no overlap, but that's okay because it's a solution of either inequality. So your final graph would look exactly like that. It only has to satisfy one of those characteristics. Okay? So again, this one ends up with two separate regions, whereas this one ends up with only the overlap of one region. So let's do an example of writing an inequality, and I put a lot of stuff on this page just because I wanted you to maybe read a little bit about pH and see where this is used. So bananas will grow in most soils, but to thrive, they should be planted in a rich, well-drained soil with a pH between 5.5 and 6.5 inclusive. This word inclusive, I'm not sure if you're familiar with it. Some of you probably are. That means it includes. So you may want to write that down if you didn't know, but it's going to include those end numbers. Write and graph a compound inequality to show the pH level that are within recommended range. So if you're not sure what pH is, some of you probably have talked about it in science. It's the measure of acidity or basicity in a solution. And I gave you just a chart just to kind of see. You may have heard that the pH of water is 7. You think of things that are more acidic, like orange juice has a pH of 3. And then bleach is up here with a high pH of 13. So just to kind of give you an idea of what pH is. And you know, pH is something that is used in science a lot. It's used in medicine, biology, chemistry, food science, environmental science, oceanography, civil engineering, and many other applications. And because I have to throw in that math is everywhere, how do they find the pH? They do math. So if you look at this equation, you may not be familiar with that yet. It involves logarithms, but it is involved in finding pH. So don't freak out. You're not finding pH right now. All you're going to do is write an inequality to represent this situation. But again, I wanted to show you that these are used in other places other than our math class. So we're going to write and graph a compound inequality to show the pH levels that are within recommended range. You can use whatever variable you want. Make sure you define your variable. So you might want to use P for pH level. It's helpful to highlight things that are important in your problem. You probably can go straight to here. The pH needs to be between 5.5 and 6.5, and this word is very important, inclusive. So we're including those numbers. Since it must be between, this would be an and compound inequality. So you're going to have your variable in the middle, and you want it to be greater than 5.5, but less than 6.5. You also want it to include those values, so make them greater than or equal to, less than or equal to. Now maybe you wrote it separate. If you wrote P is greater than or equal to 5.5 and P is less than or equal to 6.5, that's good, but let's combine it down into 1. Notice all you have to do is flip this first one around. Flip the whole statement like as if it was looking in a mirror so that the sign looks like it's reversing. But you read this from the middle, guys. So you're going to read P is greater than or equal to 5.5 and P is less than or equal to 6.5. So and inequalities are read from the middle. You might want to write that down if you're not familiar with them so that you know how to read them. Okay, so now we're going to graph this. Remember, and means it has to satisfy both of them. So I'm going to get a couple numbers on my number line. I might want to start by graphing each part. So I would have, it's going to be less than 6.5. So I'm including that 6.5. I would have a filled in circle here, and I'd be shading this way to the left. But it also has to be greater than 5.5. So I'd go to 5.5, have a closed circle to include that value, and I'd be shading to the right. So where are my regions overlapping? Where are the answers to both inequalities? You should end up with a filled in circle and a filled in circle, a filled in circle on 5.5 and a filled in circle on 6.5, and the shading is in between. If you do this part, guys, in orange, that's kind of like your rough draft in English class. So you don't want to turn that in with your final draft. You want to erase that so you're only having your final solution on the number line so I can see your graph very clearly. Make sure you define your variable. This is something that we've been forgetting. Let's solve a compound inequality, an and inequality. You could split this up. We actually have two inequalities here. We have -5 is less than or equal to 2x plus 3, and you have 2x plus 3 is less than 9. So here's one inequality, and then here's the other inequality. But if you solve them separately like that, what would you do on both of them? Well, to isolate my x here, I would subtract 3 on the right, and then I would also subtract 3 on the left. What would I do on this inequality to get x by itself? The same thing. I would subtract 3 on the left and subtract 3 on the right. You can solve them separately, or what you could do is solve it all together. But instead of doing it to both sides, you have to do it to all 3 parts. Okay, so I'm going to solve it separately first, and then I'll show you what I mean over there. If I subtract 3 from both sides here, I have negative 8 is less than or equal to 2x. Divide by 2 to get x all alone. I have negative 4 is less than or equal to x. Let me finish this problem. I would subtract 3 from both sides, and I have 2x is less than 6. Divide both sides by 2, and I have x is less than 3. Put them together, only write the x once. It's going to be less than 3, but greater than or equal to negative 4. The reason we put them back together like that is because they were initially connected. We split it up to solve. Okay, so that's one way you can do it. I also will let you solve it right off of the problem like this. So like I said, if you want to get x by itself, you would subtract 3, but not just from both sides, all 3. It's like you have 2 equal signs there. So if you subtract 3 in the middle, you have to subtract 3 on the right and on the left. I would have negative 8. Keep your inequality symbol the same and lined up, please. These 3's cancel, and I'm left with 2x in the middle. And I have a less than symbol, and 9 minus 3 is 6. What would I do to get x by itself? I would divide by 2. Instead of just dividing by 2 on both sides, you must divide by 2 on all 3 sides. I have x in the middle, pulling my inequality symbols down. And on the left, I have negative 4, and on the right, I have 3. So take a look at your 2 answers. Same answer. Both ways are acceptable to me. You can split the inequality into 2, or you can recognize that this is 2, but I can solve it as 1. Okay, so there's your solution to graph. Again, if x is written in the middle, guys, you don't have to see the word and. That is automatically an and. So that might be something you want to write down if you are unsure about that. If x is written in between the inequality symbols and there's no and or shown, it's automatically an and. So we got to graph this. We need some numbers on our number line here. Notice I'm showing more numbers on this one because I have to have negative 4 and 3. And I can't count by 2's because they're not both even. It's okay if you have to show a few more there. I want the union of this, so I would be having a filled in circle. I'm sorry, not the union. I want the intersection of this. So I'd have a filled in circle in the negative 4, and on this one I would be shading to the right because x is greater than that negative 4. And I want an open circle on 3, and I would be shading to the left because x is less than 3. So where's my region? Right between those 2 numbers. That's where the numbers would work for both inequalities. Okay? You can do your shading right on the number line, or you can put it above the line like I do, just to kind of keep it a little bit clearer. All right, I'm going to stop this video and start another one, so make sure you watch part 2.